All right. Hi, everybody. Thank you for coming. Happy Thursday. It's Thursday. Happy Thursday. Um, yeah, so to remind you, if you are still working on labs, please get them in as soon as possible. Lab 6, which we're working on a little bit today, and then you'll finish it outside of class, is due. I don't think I've updated it on Canvas yet, but I think it's due. It should probably be due like Tuesday midnight. So you should get a good start today. We're going to have 20 minutes or so to work on it and then finish it outside of class. Um, I think I've fixed the problems. So thought I had the Canvas page pulled up. Lab 6. So if you are working on Lab 6 in VS Code, which most of you probably are, delete the .classpath file and the .settings folder, and then clean the language server workspace, and that just like resets it. What I think is happening is that I wrote the labs in Eclipse, and then in Eclipse, it's saying like, use this version. And if you don't have that exact version on your computer, then VS Code is like, hi, what do I do? Everything's wrong. So if you delete those files that like are enforcing that and then do a reset, then I think everything should be fine. The JUnit jar files should also be there, so the test cases run. If you're having trouble, then raise your hand, and as I'm walking around, I'll come and help. So what I recommend, if you haven't done substantial work on it, just clone it again and then delete those two files, and then you'll be good to go. Yeah, so that's where we're at with Lab 6. Just a reminder, there's the Arthur Wynne Curley Book Scholarship for if you meet the requirements, like with the financial aid office and everything, you can get up to $250 for textbooks. So that opens next Monday at 10 a.m. and it's only open for the first 20 students who, like, if you're eligible, first 20 students who apply. So make sure to apply sooner rather than later if that's something you're interested in. Any questions, comments, other announcements anyone has to make? Cool. All right, so here's my plan for today. We're going to spend some time working on Lab 6, maybe 20 minutes or so, and then we're going to get into stacks. So I'm going to talk about stacks for a bit. We're going to draw pictures again, and then your job is to implement stacks in two different ways. One using linked lists and one using array lists or arrays. So that's what we're going to do. So you're going to work on it in your groups a little bit, and then we'll do kind of what we did last time, where we'll come together and I'll popcorn ask people for their operations, and then we'll write it up as a class. So hopefully we'll get through all of those. So we'll see. Okay, so for Lab 6, let's talk about that a little bit. So remember, Lab 6 is looking at, so we've got our linked list class, and your job is to write two methods in this class. It's the union and the intersection of two linked lists. And so the idea of like union and intersection is easy in our minds, but it's transferring it to the actual code that we write that's the difficult part. So I've got hints here. And so one thing that I think I was talking to one or two groups last time, where maybe your strategy is to, so you've got two lists, right? So let's actually, do I have a blank slide over here? I do. So let's say we've got two lists. So one of the lists belongs to this, which is like the current linked list class. And the other is a parameter. So it's B that you've been given. And so your goal is to find like this union B. And so the question is, we know the answer is going to be like 1, 2, 3, 4. But the question is, how do we get there? So my hint is maybe go through B and ask, is this element, so like if we start with 1, is this element in our current list? And we know a way to get that, right? We know in this class, there's a find method, which returns find will give you, so find will either give you, I found it, here's where it is, or I didn't find it, here's -1. So if it found it, then it'll give the index of where it lives. Otherwise, it'll give -1. So you should use find. So first iterate through B and use find as you do so. And we're looking to find the thing in B. We're looking to find like element 1, whether it's in this list. So is the element 1 from B in this list? Yes or no? If it is, then we don't have to worry about it for union because it's already in there. If it's not, then we should add it to this list. Okay, so that's my hint for union. For intersection, it's a little bit different. So let's pull up let's work with the same list. So what should the intersection be of these two guys? 1, right? That's the only element that both of these lists have in common. So we know what the answer should be. So my hint for this one is maybe instead of going through B, maybe we go through this. And we ask, is each element in B? If it is, then keep it. Otherwise, if an element, so let's take 2. If 2 is 2 in B, no, right? So should it stay in this list? No, because that's not part of the intersection. So if it's not, then we should delete it. So you may have to be a little bit careful about how you do this. This is maybe one situation where, depending on how you iterate through, you should be careful. But go ahead and give that a shot. So hopefully this explanation helps. So we're going to go until maybe like 2 o'clock and give you some time to work on this, and I'll walk around and answer questions. Work in groups, and that'll make it easier too. All right, go for it.
Yeah, that's why.
Where to go?
Oh, yeah. We're not.
All the weird areas, thanks. Okay, so the only thing is, I think you were missing. Have you made a like sensitive because in this other one? So it also has a filter, which that's like, that's what's large for state unit test cases. Yeah. So we clone it, and then. We're going. I know that you were recording. That's it.
Yeah, it's supposed to be. Yeah.
Weird areas, you know.
The weird areas are resolved, yeah, I got those, that's all fixed. I was just like, I'm bit confused on how to start. Like, I know, like, I'm trying to find what's you know, in like this, and like trying to find what's in these. I just don't know, like, how it's like. No.
Okay, so we're trying to go through B. How do you go?
Reviews fine.
So we need, the issue is we're gonna find each individual element. So like, we're gonna find one. We're gonna find is this. But we have to get to that place. This is the element that I'm currently at. We need to find it. Yeah, go through B.
Would you use this? Okay.
Through union or why? More cautious.
No, we're, and we can use it to find the. You talking about leak rate?
Inside.
Inside before.
Yes, no, it doesn't look
Yeah.
Just scroll down all this.
Yeah.
All the way down to. So much more than that.
Yeah.
I didn't know that.
Yeah.
No,
If
just.
this was called A.
Right here.
Yeah.
Oh, you actually drew it back here. I usually don't know if that was. Oh, down here on like line 229. Yeah, because there's one for unions and then there's one for.
Cause I guess, I think I'm gonna get a lot more, but
I literally.
that's fine, that's right now, like.
Come to my office. Okay. So, basically Tuesday, Thursday.
That's what he said when they told you you were missing on Tuesday.
Okay.
Yes.
Monday.
He said, I don't know, always like next week.
Did he actually? Yeah, he did, I didn't hear that. Okay.
You know, I said you had a asthma attack.
So like after the Monday.
And you think that chuckle was, I was always thinking.
I didn't hear that.
He actually said.
Yeah, might have, I didn't hear.
Yeah, I'm glad. Yeah.
That'd be honest. Very honest.
Okay.
No, I feel like he's
No, good that he's not, he's for everything else, he just.
no, he can't say if you do like, he give a letter. No, you should not. Let this. But he's like, he already said, he's one of my.
Yeah, we talked over time.
Well, you know, last
I think it's-
semester, he did like,
And. You're
Really? Yeah. He told me and then I was like, what's the name of the student? I don't even know. He said he didn't get it on Monday. But, I don't know, my grades aren't good enough, so we don't have any.
And it's working in, ML.
Right
now.
Oh, even after how classes, it's hard to not get hit.
Even after like, you like, it's like.
Those are, those,
Back to your house?
middle
Yeah.
tests.
Yeah, but that doesn't affect my grade.
Those are the.
You just
tests
had-
that you're
I
gonna-
almost got like this. Even though, it wasn't even really
Yeah, so
structured.
those are the files for next.
So what's it called?
I see.
It was Connor having problems with me, talking, and we solved it. There was no issue. But my grade was just, I not my work, so it's just like. And he didn't necessarily want to have to come intervene and say that, it's just that. Because of SDS, he has to come and he has to say something, to make sure
Then
that.
there's like
say that.
instructions like
there's-
this, they look very.
I haven't had any problem with that.
Yeah, great.
I think I got it.
So if you go back up to the instructions, there's a, there should be like.
Wait, it's not there.
Yeah, because
There we go.
yeah, it looks fine.
Yeah. Instruction.
Oh.
In a exclusive.
What exclusive?
Students use actually.
Why would you want that?
Yeah, I wanna be on
Okay, so what's your strategy?
Well, you're kind of making it easy for him.
Yeah. Dude, I literally do not.
That's the problem.
I'm not. I'm not. Wanting like students like that.
No,
no,
the class has 8 kids. There's 7 students in the class, you don't want to do nothing.
It
You know, I do stuff, I just don't like, I just don't.
So, I should just.
I don't take.
If there's like 100 kids in the lecture hall, obviously they don't need to be talking. If there's 7 people in the class, they won't be there after
I'm
them.
focused on trying to get started with the meeting.
Maybe you were talking to, maybe say like softball, what I do wrong, bro, like,
So like.
let me get on your good side.
I think you make-
He's gonna chuckle and be like,
Yeah, you never know.
I already kind of did that.
They asked you.
You need to know.
What did I tell you?
what he said.
I was just talking about something else, and he was like.
Yeah. You need to find each element
So the first we went outside, it's we're on your phone.
in this.
And everyone went outside. I don't understand is everybody does that. Yeah, but like, people, other things too.
My whole group was.
He knows that good work, he doesn't work on like capstone.
So they have to make them.
You don't even have to.
Yeah, like, down.
Well, are you guys already working on it?
We just had a budget, what to do, and we told softball, he's like, that's good. Oh, he's like, "Work on it." Yes, so-
You should take the chat off your.
I'd rather you did the shot ball last year, like, can't do Jackson this year. That was.
Isn't that a Jack did a capstone? Jack repeated the capstone and the NLP, they were like a similar, they were pretty similar.
That's what I'm gonna help you get. The good votes.
You know how to be a softball business, you gotta talk in class, you know, you gotta like say something of something. You gotta think you have something to contribute to the class. They can be like, wow, it's a good student.
Wow.
Say so.
Alright.
Hey,
My dog has his life now, he likes me, right?
You are, yeah.
Exactly, what about if you just talk?
Yeah.
Yeah, he doesn't care if you do like the 8 hours for hours,
I would focus on like,
he cares about like,
yeah, some lab and
have something to say.
So wait, are you guys getting the?
that.
I think after this, we can take the test.
Yeah, we get a discount, I think he said.
Is it not a big word? Good.
We're here to set items.
How's the lab?
I'm not working on that right now, because I'm not on the weekend, that's why I'm doing my life. So here, guys, finish it right now.
I mean, this time is it, was
I'll start working on it.
No, I appreciate that. You have a strategy that you're trying to think about? So how do you iterate through? Yeah, so like habitats, whether wow, that's inside.
Yeah, what are you saying? I'm saying like maybe.
So if you go to the Elo doc,
Remember that class we started to write?
I think-
This class?
With.
Which is the whole year.
There should be a line in here. I just set I equal to 0 outside.
So we start kicking off. So we start the chunk. And then. It asks, is this what we're looking for? And this is the return to the index. So you can take that code and modify it. Like, we're not going to return a number. We're going to modify it. That's the way to start doing it. And
Looks like I on that issue that he had.
Yeah, we're responding right now. I already included with it.
We've been in the data for back in the day, like,
Alright. So we're gonna be working together.
so what's your schedule? I wonder if a while.
I've never been satisfied. I usually just. I just like. We're waiting it. Like in terms of just like following this, like I'm gonna follow start out here. That's that one, right?
I just don't think I.
Recognizing what you especially when it's kind of like working with it spontaneously. It's five already. Like 5 minutes later, like it's. Don't even go. I mean, it's not.
Something that goes.
At least that's what we're doing. We're just letting it wait.
And then either. And that is this. If it is, if it's not in this way. So, yeah, so start with.
So you have issues with the data science? I don't know if you're comp-sci data science. You can't even take out the classes that aren't operating. Like this, half my classes got well. We got even on graduate, but they only operate in the blue room. We're working on strategy.
In the element.
It's literally. I don't know how to start it because I'm not sure. Yeah.
So.
I probably need to use five. I'm trying to figure out what, like, how do we iterate?
That's gonna say something as well. I don't think this is gonna something. How to increase the something that.
Well, this.
Setting class and then have it actually.
Okay, so start writing your while loop in the person.
I was confused because I was looking at, so this time it would just be, right? And it uses a one. And so we want to iterate through,
It's a good class.
And then use it to find, if like, find things in this and add it.
Yeah, he's a big,
into
well, he works at Ames.
No, add
National
this,
Labs.
add things into this,
He
yes.
drives here, like.
Okay,
so
and
he's-
so we want to also use the
Which one?
Or do you want
Yeah,
to
this
use
one there.
it?
Oh, yeah, he's a.
What is it?
I didn't know he drives as much as that class.
Doesn't matter. Okay.
Yeah, no, if you were in that class, you talked about the fact that you wanted to get that job. Yeah, cause he was some trash, yeah, company where.
Yeah.
like, the-
He was at a startup, right?
Yeah.
Oh, yeah, he's not- he's not letting-
Yeah, no, he's been finding,
And he got
he got the job. We really have.
And then-
we really have-
I thought you said hospital, you guys, I think I don't why you're doing hospital time.
And then
Another job.
update status.
I'm really glad you're here. Well,
Okay,
So it's very similar to this,
yes, except you're not having that if.
You are.
instead of doing a fine.
Yeah.
Oh, okay. No more.
So yeah, so we're going to be going to reunion over to go teaching. And so how do we go through? So yeah, so we need to find. So how do we set up the live? So we need, one starts at the head. And then we'll say, wow. We'll say, wow, 10 is not null. And then inside, so we'll have the update.
Oh, sure.
That's how we hard.
Oh, you copied all of it.
Yeah,
You copied
I like it.
mine too.
I've done it like three
So
times.
what's your plan for getting yourself a good sense?
Just because then I can. use it.
Sounds like I just have to, like raise my hand before he calls on me.
Maybe also like
Fine.
showing up to class a little more often.
I do.
Dude, you yourself saying you're already taking too many days. Okay, okay, I'm sick right now.
There are days when I get really sick though, that's the thing.
Okay.
Okay, that's fair, that's fair. I think how we use it, that's really good. You should understand that you're very. Yeah, that's true.
His first thought shouldn't be like, oh, first thought should be like, oh, it sucks, so we get iterate.
Well, you can't control how we react, so how we act.
Yeah.
You need your initialization, your condition, and your update. What's your initialization?
Well, I was getting recorded, I didn't even know it was that side.
Oh.
Dude,
Yeah, she just.
like, the opponent's asking me.
That's like saying, so instead of the.
You want to start
If
at
sleeper and then you said the line, what is it? Move this one now we're through lines. And we're gonna find, until this, the element in A, and then trying to add them to this list, and then it will have.
Very, we just enter attendance and then that.
But I'm not sure exactly.
One
what,
guy.
If you needed- it's like a fine number of each line.
Did you give a midterm grade? No, ask.
Student five has.
He doesn't do that.
Dude, you For the.
Does he do the midterm grade?
We want to start temp at the first thing in B. So maybe, so,
The first one.
yeah, the first element in B, I think I should have a, let's see. Get node. You could call get node. Where did it go? Get node 0. That could work. And so that serves as your initialization. And then for your condition, what's your condition? Or like removing temp through B. At what point are we, so our update step is temp equals what? How do we take the next link? What method does a node, so a node's got its data and its next pointer. And so for our next pointer, we've got get and set. So how do we get whatever is pointing after this node?
Well, I'm kind of happy with it. I love the world. I want to walk. If we walk next door, there's so much like junk we walk into. It's in 90% of the stuff we're gonna be learning about is gonna be like shit coins and random scam projects and all of our favorite. Huh? I'm not here, I was minding here.
And so eventually for this list, we're gonna end, so eventually this list won't have anything at the end. Like it's gonna end at some point. And so what do we call that ending? Or it's nothing. So, and the way we say nothing in Java, no, yeah. So we'll say while temp is not, yeah. So that's how we structure, that's how you'll structure either your while loop or your for loop. Yeah. Okay. All right, so let's come back and so I'll let you work on this after class. We may have some time on Tuesday as well, if you're still stuck, to keep going through it. If you have questions, come to office hours. I'm happy to help. But for now, we're gonna move on to stacks. So we've talked about linked lists, and linked lists are really helpful as like the underlying data structures for us to do a bunch of different things. And so even though like linked lists may not be the most optimal way to store this information and retrieve this information, like because computers have advanced to a point where it's a lot faster to use other data structures. Learning linked lists is really important because it teaches you the basics of how do these data structures work? How can I like implement these operations to do these things? So that's why we're learning about linked lists. And so now we're going to move into some structures that can use linked lists as like we're using linked lists to implement these structures. And so the first one that we're looking at is stacks. So let me get out of this. Where did I put it? There it is. Okay, so we'll start with stacks. And a stack is a really simple data structure. One of the things I like to liken it to is if you've eaten out of a Pringles can, if you've got your Pringles can, you can reach in, take out a chip. If you wanted to, you could put the chip back on top. But it's really hard because the can is so small where you can't like reach in, grab one below the one that's on top and pull it out. Or you can't, if like you were super determined, you could like carve a hole in the side of the can and grab it and take it out. But that's not the goal, right? The goal for this Pringles can is to take the chip that's on top And that's what it allows you to do. That's basically a stack. So a stack, we can draw it just as like a box with an open top. And we can put things into this stack. And the thing on top is the thing that's most accessible. So let's say, so the other example is like if you go to Safeway and from the other side, they load in like the gallons of milk. And so when you're in the store and you're on the other side, you can open the door and take out the gallon of milk, and then the rest of them slide down to the front, right? If you wanted to, you could like push back the milk and then put the one you put back, but you can't like reach over and take like the third gallon of milk. You just take the first one, the one in front. That's a stack. So a stack is a data structure that only has two operations, or maybe three, to what we call push, which is add something on the stack, and to pop, which is to remove something from the stack. The third operation is peek, which is where we like look at what's on top of the stack, but we don't modify it at all. So let's look at an example where we'll look at arrays and array lists in a second. So let's say I want to push all of the letters in, let's say, hello to the stack. So we'll start at H and we'll go through O. So we'll say, first we'll say push H, and then H goes to the bottom of the stack. And then we're going to push E. Now E goes into the stack. It doesn't go below H because H is already there. So it goes on top of H. And then we do L, and then L, and then O. And so this is what our stack looks like. So with a stack, the only things we can do is we can only modify or look at the top of the stack. So this is what we call the top of the stack. And as we've added things to the stack, the top has changed. So like at the beginning, it was just H. That was the top of the stack. When we added E, E is now the top of the stack, right? It makes sense. Like if you're stacking something, then there's something that's new on top each time. And so then let's say we want to pop everything in the stack. So remove everything from the stack and then, I don't know, like print it to the console or something. And so if we call pop, we don't have to add any arguments to pop because it'll just take whatever's on top and return it. And so that's going to give us what at first? O, right? O is the thing on the top of the stack. So we'll pop O and return it. That gives us O here. When we pop the next thing, L, right, it's not a trick question. And then we'll get L again. And then E. And then we pop one more time. And then we get H, and the stack is now empty. So when we pop something, we remove it from the stack. So it's not in there anymore. So what we do when we got that is we've got our string hello, but it's now in what sort of order? Yeah, it's backwards. So we've gotten the thing in reverse order. So stack is really useful if we need to reverse something. We just load everything on the stack and then pop it off to get it in reverse order. And so a stack is a kind of data structure that we call it's first in, last out. So sometimes you'll see like Philo, which first in, last out. Sometimes you'll see LIFO, which is last in, first out. It's the same thing. Like the first thing you load in, that's the last thing that you'll get out. The last thing that you put in is the first thing that you get out. Okay, so what I'm gonna have you guys do today is try and write up some code. And so we'll start with using an array. So let me actually, I want to keep this. So we're going to talk about how we would implement this in an array list or an array. And then your job is to come up with the code that does this. So we know what a stack should look like, right? It's going to be this structure, and the stack has a top, and it's got three major operations. There's push, where we give it some element that we're going to add to the stack. We're going to do pop, where we remove an element from the stack. And then there's peek, which just takes the element it returns the element at the top, but it doesn't remove it. So pop removes and returns. Peek just returns. So that's like if I've got this deck of cards and that's my stack, and I to pop something off this deck of cards, I like take this and put it somewhere else. But to peek, it's like I just look at it and then I put it back down. Okay, so how do we do this in an array list? So the things in the stack are ordered, right? The order that we put them in matters. So when I add HELLO, I would expect to get it in a similar order. So in this case, we get it in reverse order. It's not like all jumbled together. So the order that we put these things in matters. So what would be the easiest way to put let's say we are pushing hello to the stack, and we want to do this with an array list. So the way that we're choosing to implement a stack is with an array list. That's how we're going to hold the data. How should we do that? Yeah, Nathan.
Setting for like letters to like the numbers and whatever, so like would I think I'm wondering about that. So like because you said that's going in but it's being reversed because it began to go in first like first.
Mm-hmm.
So would the H be 0 or would the O be 0?
So we push it in a specific order. Like first we push H. And so we wouldn't want to put O in first because we're not pushing O.
So would the H, so you guys were pushing it in first, would it just automatically like be the last number in the array, or would it be still considered like 0, like order wise in the array?
Yeah, that's a good question. What do you guys think? So I think it probably makes sense to like, we'll put H here to start with. And the way that we're going to do this with an array list is we're going to have, so it's a little bit different if we do it with array list versus arrays, because array list will handle a lot of things for you. So let's assume we're doing this with array list. We append, so to actually do push, we would do like a.append that element. So like if this array is named A, then we'll append each thing. And so that would be like HELLO. And then we can call, I think it's a dot remove. Forget. Yeah, it is remove. And so we can give an index to remove to be like, okay, now this element, take it away. So here's the next question. So if we've got something that represents the top of the stack, what is that in array list terms? So we add something to the list, one after another. What's happening to the list as we do that? The order, wait, say that again. Yeah, it's getting larger. So the size is changing. So we can use the size to represent the top of the list. So like that's the index of, or it'll be size -1, which is the index of the top of the stack. So here we're gonna want to remove size -1. And that's how we're gonna do, so this is for push, and then for pop, or for just pop, we're removing it. For peak, we still want to use this size -1, but what sort of thing can we use for a list to just get it and not change it? Yeah.
Can we call like the number it is in the list?
Yeah, so I think array lists have like a dot get. And so we can just use that size -1. And in that way, we can just like grab the list. Okay. Okay, so that's push, pop, and peak. And we know size. So that's how I'm gonna have you build the code out for this. And we're going to write some code to do that. Okay, so I'm going to make a folder stacks. And then to start, so since we're going to do this with two different data structures, we're implementing stacks with two different data structures. We're going to do it with array lists and with linked lists. So I'm going to make an interface because I know what a stack should do. I know that my stack is going to have these methods and this is what they're going to return. And so I want to implement that interface in the ways that in these two classes. So let me make a new file. And I'll call it stack.java. And then instead of class stack, I'll do interface. And they'll say, let's see. Yeah, okay, so the other thing we want to do is we're gonna want to parameterize stack because a stack's gonna hold objects of some kind. So we're gonna say a stack holds things of type T. And so we'll have it push things to the stack. The return type is void because we don't need to return anything. for pop, we need to return something. And so the type of things that are in our stack is T. So we're gonna return the object that was at the top of the stack. And then for peak, it's similar. We're just not going to modify the list or the stack. Okay. So now we've got our interface. Now let's make the linked list, or not the linked list, sorry, the array list stack. So I'm going to make a new file and also call it, I don't know, AL stack for array list. And so I'll say this stack is going to implement my interface that I've just made. And so then we've got some errors here saying we haven't done peek, pop, or push yet. So we can click on quick fix and add them all. And then we've got it'll add them for us. And now we have to actually implement them. Okay, so this class is going to want a field, the thing that we're actually going to store the data in. What is that? This is what we're trying to get to. To have this list, what's our field? Not a trick question. Yeah. Yeah, it's our array list. So we'll have oh, we've got to parameterize the class. And so because we want the array list to store things of type T, because those are the things that are going to be in our stack. Let's import that. Then we'll probably need a constructor. So I'll do right click, source action, constructors. So that's the basic one. And then we'll also have a zero parameter constructor to just set up the array list. Okay, so your job, that shouldn't be object, that should just be T. So your job is to implement push, pop, and peek. So using an array list, how can we do these stack operations? Okay, so yeah, so work in groups again and implement these after I'll give you a little bit more time to copy it over, and then I'll go back to the slides. All right, so once we've got our class set up, then your job is to, how do we add things to the stack? How do we remove things from the stack? Using array list methods. So yeah, so working groups again, go. Good. So if we're gonna test the stack, let's say we want to have it hold strings. Maybe I'll call it the stack or something. That's the variable name, could be anything. Then equals new AL stack. Now we've got our stack variable that we can push and pop things from. So we can say the stack dot push and then H. Okay, so this is going to add the things to the stack. So what should I do for push? So for push, we're gonna want to change object to T, but from there, how do I add something to the stack? I know at least one. Do you want to go for it? Right. So to add something to the stack, we just add something to the array list. And so what add does for an array list is it appends the element to the end of the list. And so that's what the sort of thing that we want to have happen. So that's great. And then for pop, how do we remove something? Yeah,
Return. And possibly.
mm,
The array dot remove. Array dot size and
yeah. And I think Anthony figured out that remove last also worked. So like size -1 is fine. Remove last does the same thing. So, and why are we returning it? Yeah,
returns what you're removing.
yeah. And so the idea with stacks is we want to give someone the thing that we just removed. So like if we're drawing cards from a deck of cards, we're gonna draw a card and then like give it to whoever wanted that card. Like if we're the, I don't know, the dealer in a game of cards. So yeah, so remove last returns it. We also want to return it. So this is really important. So, and we can't just say like, just remove it. We want to return it ourselves. That's the sort of thing that we want our stack to do. Okay, how about peak? Who's got peak? Let's see, get last. There we go. And then since we want to return something of type T, we also return it. Yeah. Let's think of some other helper methods. How do we know if the stack is empty? What's holding our stack? Yeah, our array list is holding our stack. And so if the list is empty, then there's nothing in our stack. So we can say the array knows whether it's empty or not. I've got to say what return type this is. Whoops. So we can say if the array is empty or the array list is empty, then my stack is empty. Okay. So if we push those, now let's try to pop it. So let's say while the stack is not empty, then we're going to say the stack dot pop. And maybe we want to so let's print each thing that we pop. And so ideally, since we've pushed HELLO, we know what we should get. We should get OLLEH, right? Okay, so let's give that a shot. There we go. So we've pushed HELLO, and then when we pop everything, we get it in reverse order. Great. That's the goal. Let's try another example. So instead of HELLO, let me comment these guys out. And then I'll say maybe let's add 0 to 9. And then if we pop everything, we should get 9, 7, 8, 6, 5, 4, 3, 2, 1, 0. So first we have to push things to the stack. And so what should we say to push it to the stack? So first we'll probably need to change it. Because instead of strings, the stack's gonna hold integers. So now how do we push something to our stack? Right? We're gonna want to call like dot push. Like not a trick question, not a trick question. And so if we're pushing integers, what are we going to give it? Right, we're in a for loop. We've got an integer called I. Let's give it I. And so we start I at 0, and we go until 9, increasing by 1 every time, what's in our stack? We're getting 0, 1, 2, 3, and so on up till 9. And so when we pop it, we would expect to get first 9, and then 8, and then 7. That's looks like a 2, but that's 7, and so on until 0. Yeah, so I did change the type of thing, the parameters in my stack variable. So yeah, so that's now set up to hold integers. Okay. So if I run this, let's see. There we go. 978 654 3210. Hooray. Okay. So that's a stack. That's so now we've implemented this data structure that does these things. So it pushes, it pops, and it peaks. Those are the 3 main components of this structure. And so we have implemented it using array lists. And next we're going to implement it using linked lists. So we've implemented using one data structure that we know how to work with. Now we're going to use another data structure that we know how to work with. So if we've got a linked list, so we know what a linked list looks like. And we know what we want our stack to, how we want our stack to work. What do you think is the best way to translate a stack where we have we maintain the top of the stack somehow? Talk with your neighbor for 2 minutes. How can we represent a stack using a linked list? Go. Ants over there again?
There's so many ants. I don't know why they're like getting used. I think it's on something.
Thanks. All right, so how should we represent a stack as a linked list? What do you think? Go for it. Yeah. Mm-hmm. And so then when you add something to the stack, when you push something to the stack, what happens in the list? So pushing is adding something.
Oh, right. Or the size.
Mm-hmm. Okay, so let's say we've got, so if top is equivalent to the head of the list, let's say we add, or like we're pushing 1. We've got a new node. It's the top of the stack. Also the head of the list. What happens when we try to add 2? Does it go here? Or does it go here? Let's choose one and see what happens. On the left one. Okay, so what's this the case of? When we were talking about linked lists?
Yeah.
What's this equivalent to? Yeah, beginning, yeah. So when we do this, the idea is, okay, we've got this new node. Now it's pointing to the old head of the list. And then now top points to our new thing. Is that what we want to have happen? I see a no. Why?
Well, I love the main objective of the top of the stack, or to make the stack equivalent to the list, so the top of the stack would be the head of the list.
Yeah. And is that not what's happening here?
And it tends to be pushed to or maybe add.
So for a stack, push is the name of the operation where we're adding something. So when we push, we add to the stack. That's the only operation that like stack only cares about push pop. So push is add, pop is remove. So here I would argue we have pushed 2 onto the stack. So like in our stack representation, we've got 1 on the bottom, now 2 on the top. And if we looked at our linked list representation, the top is pointing to 2, and then 2 points to 1. I think this is the goal. So I think if you had chosen this one, we would try and see how that would work, but we would have ended up as that's not what we're trying to do. But this is what we're trying to do. So we're going to use linked list operations. We've defined those, and we're going to use those to make a stack. So like the stack is going to wrap around the code that we've written for linked lists, and we're going to be able to call push and pop just using linked list stuff. So we've done it using array list stuff. Now we're going to do it using linked list stuff. And so we just have to draw pictures first to figure out what are we trying to do? Is this the way that we want to do it? Okay. All right, so that's push. So for push, we are inserting at position what? Inserting at the beginning. And so what position is that? Index wise. 0. Yeah. Because we're inserting to the front of the list. Yeah, so if we inserted 0, then that does that for us. And we don't have to worry about we won't have to worry about like setting the links because we've already done that in linked list. We don't have to do that again. We're just going to call it. Okay, so let's say pop. Let's now try to remove 2. What linked list operation should we use to get this done? Delete, yeah. So I forget if delete. Let me look at this. Delete. Yeah, okay. So yeah, insert and delete. I forgot what I called it. I think remove from the lab. I think remove removes like a specific element. But delete takes an index. And so what index should we be trying to delete? So when we pop from a stack, we're always trying to remove the thing at the top. So when we delete from a linked list representing our stack, what thing are we trying to delete? Yeah. Yeah. So we're also trying to remove the thing at index 0. And so when that happens, head's gonna not point to 2 anymore. Head's gonna point back to 1. And then the important thing is we have to return the data that's in here. So we have to return the data. But other than that, that's about it. Okay, so let's get set up, and we might run out of time before we finish all of it. But let's go back to my stacks folder, and I'm gonna make a new file. I'm gonna call it ll stack.java, stand for linked list stack. And so this one is also going to be parameterized. It's going to hold some type of object, which we call T. And again, because the stack interface is where we've said these are the names of the methods that I want any stack to have implemented, we're going to call implements stack. So then it gives me an error saying I haven't implemented these methods. And so then like before, it pulls up, here's all the methods that you have to implement in order for you to properly implement the stack interface. Okay. So what sort of fields do we want? We're storing our stack in a linked list. What field do we want? A linked list. So we'll use our LL class that we've written. I'll call it list. You might have to import it. So quick fix. So for me, it's like, oh, you've got a LL class that lives in the linked lists package. And so it'll say import package name dot class name, because my linked list, my ll.java lives in my package called linked lists. And so it can import that automatically. Or when I say import that. Okay, do we need to keep track of the top of the list or the size of the list? Maybe, maybe not. Does my LL class have all those things? Yeah, I would say so, because LL's got, let's look at it, it's got the head of the list. So we don't need to worry about that. We're going to treat the head of the list as the top of the stack. And it's also got the size field. So LL already has all of that. So we just need the list as a field. Okay, so with that, we'll take the last couple of minutes and I'll let you work on push and pop. And so now instead of using array list methods to add things to the stack or remove things from the stack, I want you to use linked list methods that we've written. Okay. Okay, so I'll add a constructor just to set up the list. And then what should my push method be? To add something to the list, add something to the stack. How do I add it to the list? Insert, yeah. So list is or did I name it list? I did. Dot insert. And it takes an index, which we've decided will be what? Yeah, because we're inserting to the beginning of the list. Yeah, so 0, and the data to insert is X. Excellent. What about pop? This may be, we may have an additional step. Right, so we want to return the thing that we delete. How can we save that? Do we have a get method? We've got get node, that's private. Got is empty size. We've got find, but that just gives us an integer. I don't think we made a get method for a linked list. Maybe we should probably have one. So let me go down to the end here and let's make one. So what sort of thing are we returning? If we're getting the actual data, what's the type of thing that we're storing in this list? We've parameterized LL. Yeah, it's just T. That's our return type. So if we're given an index I, then we just, it's kind of like get node. Actually, I think we can just say this dot get node, because that's set up to return like just the node that's at index I. And so once we've got the node, what can a node give us? It can give us like its data. So from there, we can call dot get data. We just return that. So now if we give our linked list an integer, an index, then it will get the node at that index and then get the data and give us the data. Okay, so once we've got that, we've got 1 minute left. So list dot get probably. So if we want to get the thing in index 0, we can't just return that right away. Why not? Right, because we haven't actually removed it. So we're probably going to need to save it as a variable, and then we can remove it. So list dot delete. Do we want to delete the thing at index 0? No? What do we want to delete then? So the way that we're structured our stack as a linked list is the thing at the head is the top of the stack. And so in this case, we do actually want to remove the thing at index 0. So then so we call list.delete 0, and then we can just return X, which we've saved. Okay, so for active learning today, if you can submit LL stack, that would be great. And then, yeah, that'll be it for today. So let me add that. Yeah. Yeah, I'm adding that right now. What's today? The 24th? All right, thanks for coming, and I'll see you on Tuesday.
Oh, yeah.